Hello, I'm Dave Brown, and today it's basic terms. There are a number of words and phrases which are common to many areas of industry, and today we're going to discuss several of these. First, we'll pick a few words at random. For example, force. Force is what this box, which weighs 50 pounds, exerts on the table. That is, 50 pounds force downward. And when the young lady tries to lift it, she's exerting force upward. Okay, now let's get one more definition. Work. Work equals force times a distance. Now remember, this is a definition which has been assigned to work. Now back to the box. By definition, no work has been done on it until it moves. Now if it is lifted 1 foot, since it weighs 50 pounds, we have 50 times 1 foot equals 50 foot-pounds. So work equals force times distance and can be measured in foot-pounds. Torque is probably a new term to you, but it is one to remember. It's the twist in a shaft that has one end fixed and to which a twisting force is applied. It is also measured in foot-pounds. Here, a foot-pound is a measure of twist that will be produced in a shaft by the leverage of a lever 1 foot long, which has 1 pound of force applied to the end of it. If we take a wrench 1 foot long and put it on this motor shaft, when the motor starts, the number of pounds of force here at the end of the wrench will be a measure in foot-pounds of the torque that the motor will develop. Okay, let's try it. We hook a spring scale onto the wrench at 1 foot from the shaft. The wrench is the lever arm, and we start the motor. Now, as you can see on this 10-pound scale, the scale reads approximately 7 pounds. This, then, is the motor's starting torque, 7 foot-pounds. To convert this to inch-pounds, all we have to do is multiply by 12. That is, 12 inches per foot. So many pounds at so many inches lever arm. Since the shaft isn't turning, this is static torque. The next formula, beyond the one for work, includes the factor of time. It is stated power equals work done for a period of time. In a shaft that is turning, torque is a measure of power and is specified as torque at a certain number of revolutions per minute, or RPM. Here we have force in foot-pounds times distance, revolutions at 1 foot lever arm, times time, 1 minute. A good fact to remember for quick calculations is that a torque of 3 foot-pounds at 1750 RPM equals approximately 1 horsepower. Horsepower, or HP, is another way of measuring power. 1750 RPM is the most common speed of an electric motor. Since torque is twist in a shaft, if we put some sort of slip clutch into the system, such as this one, it is called a torque limiter. Theoretically, a mechanical horsepower is 1 1/2 times the amount of work that an average horse can do continuously. James Watt came up with this definition as a way to rate the power output of his steam engines. And I've often wondered how he decided what was an average horse. But anyway, he defined mechanical horsepower as the amount of work done in lifting 33,000 pounds 1 foot in 1 minute, or 1 pound 33,000 feet in 1 minute, or any combination which would equal 33,000 foot-pounds per minute. Electrical power is measured in watts. Expressed in electrical terms, 1 horsepower, or 1 HP, equals 746 watts. Now 1,000 watts equal 1 kilowatt, or kW. So 1 horsepower equals 0.746 kW, or kilowatts. This, then, is another fact to remember for quick calculations. 1 horsepower equals approximately 3/4 kilowatt. There's a problem which comes up relatively frequently: how to determine RPM of a driven unit. And there are a couple of easy ways if you have the proper equipment and the unit is accessible. First, there is a unit which is known as a tachometer, which operates something like the speedometer on your car. It reads directly in RPM, as you see here. Next, there's the strobe tach, which is a relatively new item, but it electronically counts the reflections per minute from a piece of tape, which has been put on a turning unit. But what if you don't have a tachometer? Okay, usually the motor has a nameplate, which will tell its RPM. If the pulley or sprockets on both the driver and the driven have the same diameter, that's the distance from here to here, and here to here are the same, then the driven speed will be the same as the driver's speed. But what if we have a situation like this, where the diameter of the driver is 3 inches and the driven is 6 inches? Okay, now we have a formula. Driven speed equals driver diameter divided by driven diameter times driver's speed. So we would have driven speed equals 3/6 times driver's speed, or driven speed equals 1/2 driver's speed. It should be noted here that when the term diameter is used, we are actually talking about pitch diameter, which is from a point from the middle of the belt to the middle of the belt on the opposite side of the pulley. While you will probably not be able to measure pitch diameter exactly, you will be able to be close enough for most applications. If you're using a chain drive, then you only have to count the number of teeth on the driver and the driven. Our formula now becomes driven speed equals number of teeth on the driver divided by number of teeth on the driven times driver's speed. If you should become confused as to which goes on top and which on the bottom in the formula, just remember that the larger diameter, the sprocket or pulley with the larger diameter, will always turn slower than the smaller one. So if your answer comes out with the large pulley turning faster, then you'll know you've made a mistake. Pure iron is relatively useless in industry, while cast iron and steel are extremely important. The only difference in pure iron and cast iron and steel is the carbon content. Cast iron usually ranges 2.5 to 5% carbon, while steel is in the range of 0.05% for certain low-carbon steels to as high as 1.25% for razor blade steel. Cast iron is relatively resistant to corrosion, tends to dampen vibration, is easily castable, and its machinability varies with its hardness. It has relatively low tensile strength, which means a bar will pull apart relatively easily as compared to steel. It will take high loading when it's being pressed on, such as base plates on a press. It is not ductile at all, which means it won't bend or can't be formed. Malleable iron is cast iron which has been heat treated and as a consequence has many of the properties found in steel. It is ductile, it has a relatively high tensile strength, and is the easiest to machine of all iron products of like properties. Malleable iron is widely used for pipe fittings and many cast chains used in industry. Ductile iron, or nodular iron, is a relatively new type of cast iron. By the addition of small amounts of alloying materials and special processing during melting, a material is produced which is about halfway between steel and cast iron, with many of the desirable properties of each. Carbon steel has a wide range of properties depending upon its carbon content. The main difference in the steel in this wire and the steel in this razor blade is carbon content. The more carbon a steel has, the less ductile it tends to be, and the harder it can be made with proper heat treatment. Stainless steels are alloys or combinations of steel and one or more additional metals in varying properties which were mixed while melted. Nickel and chromium are two of the more common alloying metals. However, several others are used depending on the required properties of the alloy. Heat treatment. Heat treatment is a method of changing the physical properties of metal, usually to make it either harder or softer. The metal is heated up to some temperature less than its melting point. How long it is left at that temperature and how rapidly it is cooled will help determine its final properties. If it is chilled quickly, such as by placing it in oil or water or some other medium, the process is called quenching. Each particular metal or alloy has its own heat treating procedure. For example, carbon steel is hardened by heating and then quenching, while copper is made soft by the same process. Heat treatment is also used to relieve stresses in metal. Stresses in metal are internal forces which tend to make the material unstable. For example, a piece of cast iron which is welded may have such high stresses set up in it that it may crack as it cools. If, however, the cast iron is heated up before welding, called preheating, and it is heat treated, that is, it is raised up to some predetermined temperature after welding and then slowly cooled, the stresses are relieved and it won't crack. Of course, as in all welding, a welding rod suitable to the material being welded must be used. Welding is the process of joining two pieces of metal together, usually by melting the edges of both the pieces to be joined. This is usually accomplished with a welding rod through which we pass an electrical current which makes an electric arc and thus melts the two edges to be joined. Usually a filler or welding rod is used so that the final weld normally has a raised surface. This melting can also be done with an oxyacetylene torch like this, which uses a mixture of oxygen and acetylene. Joints of lesser strength can be made with filler rods called solder, which are alloys which melt at a temperature less than that of the two materials to be joined. In soldering, the edges of the parts to be joined are not melted. They are instead coated, or wetted as it is called, with the molten solder, and the two parts are joined while the solder is molten and allowed to cool. This joint then is only as strong as the soldering material. There are three basic types of solder. First, there is soft solder, which is used on things like electrical connections, copper plumbing fittings, and sheet metal work. It is an alloy of lead and tin and melts at approximately 360 degrees Fahrenheit. Next is silver solder, which is an alloy of silver, copper, and zinc. And it melts at a temperature of approximately 1250 to 1600 degrees, depending upon the alloy used. Silver solder is widely used in refrigeration work and in the jewelry trade. It makes a relatively strong joint and is frequently used in industry to join two different metals together. The third method of soldering is called brazing. Brazing is identical to silver soldering, except the solder is usually a brass rod, which means it's an alloy of copper, zinc, and sometimes small quantities of other metals. When either welding or soldering, the two parts to be joined must be cleaned, and a flux is usually also required. Flux is a substance used to prevent oxidation of the hot metal surface and to help clean it of any oxidation which is already present. Oxidation of steel is called rust. A variety of materials are used as a flux, depending upon the work to be done and the particular kind of solder used. Elastic limit is a way of defining in terms of unit loading the extent to which a material will stretch or bend and not be permanently deformed. Unit loading means so much load applied to so much area. The load is usually in pounds, and the area is usually a square inch. Thus, if we have 1,000 pounds load applied to 4 square inches area, then the unit loading would be 1,000 divided by 4 equals 250 pounds per square inch, or 250 psi, as it may be shortened to. If we had 1,000 pounds applied to an area of 1 inch, the unit loading would be 1,000 divided by 1 equals 1,000 psi. This is the force on a part of 1 inch cross-section. And what is the cross-section? If you can imagine this stick of margarine as being a piece of steel 1 inch square, then its cross-section would be right here, a section across the material. As you see, this spring can be loaded or stressed and will repeat this cycle many thousands of times as long as we do not exceed the elastic limit. But if we stress it beyond the elastic limit, like this, then it won't return to its original position. Yield point is the point at which there is an appreciable increase in deformation without any additional load. For most ductile materials, that is, any material that can be easily bent or formed, the elastic limit and yield point are very nearly the same, and they're sometimes used interchangeably, although there is a slight difference. Once again, the loading is normally expressed in terms of pounds per square inch. Ultimate strength is the most loading a material can be subjected to before it fails. Working strength is the unit loading at which experience has shown the material can reasonably be expected to serve for its design life. Working strength, or working stress as it is usually called, is always considerably less than either ultimate strength or yield strength. The ratio between the two, that is, ultimate to working, load may run as high as 10 to 1 or more. This ratio, then, is what is known as a safety factor, or it is sometimes called service or experience factor. Through the years, experience has shown that for a certain kind of service, a certain safety factor will have to be used if the unit is to perform satisfactorily. In some applications, ultimate strength is the limiting factor, while in others, yield strength is. So hence the two different formulas. Fatigue failure in metal is a break caused by repeated application and release or reversal of a load which does not exceed the elastic limit. That is, no permanent deformation takes place. Nothing is permanently bent. But the continual stressing of the material frequently causes a hairline crack to develop, which gradually works its way across the stressed material. This type failure usually takes place after millions of repeated cycles. For example, if we take a door spring like the one we used a moment ago and loaded it to just below its elastic limit and then release it, the spring will probably suffer fatigue failure after 1 million or so repetitions. Press fit, force fit, or interference fit are all terms denoting the assembly of something on a shaft or pin where the hole is smaller than the shaft or pin. The amount of interference varies with the service, but a rule of thumb is 1/2,1000th per inch of shaft diameter. And the term rule of thumb means something which through the years has been found to work in most cases. Handbooks have tables indicating tolerances which should be referred to where service is critical. The part is normally forced or pressed into place, hence the term press fit. Press fits are normally used together with a key and a keyway like this. Here is a key, here is a keyway. If the assembled part is to transmit power to the shaft, then a key must be used to lock the shaft into position, key lock. Press fits are used to assemble items such as gears onto shafts, or for mass-produced items such as roller chain, for example, where the pins and bushings are a press fit into the side plates. Shrink fit makes use of a property of metal called thermal expansion, which means as a metal is heated, it expands. So we take an item such as a gear to be mounted on a shaft, which has an interference fit, and heat it to, say, 350 degrees. It will be larger than the shaft and will slip right on. And when it cools, it will resume or try to resume its original dimensions and will be shrunk on the shaft. Since we've been discussing temperature in terms of Fahrenheit, it should be explained that this is a scale of measuring temperature where water freezes at plus 32 degrees and boils at plus 212 degrees. Industry also uses a scale of temperature measurement called centigrade, and under this system, water freezes at 0 degrees and boils at 100 degrees. And as you can see on these two thermometers, the Fahrenheit reads about 78 degrees, while the centigrade reads about 25. When writing it, the notation degrees Fahrenheit, F, or degrees centigrade, C, designates which scale has been used. If an item is made from steel of proper carbon content, which is usually about 0.35 to 0.60%, flame hardening is a quick method of hardening a thin section on the teeth of a gear, a sprocket, or a similar item. In this process, we heat it up with a special oxyacetylene torch and then quickly quench it with water. Case hardening is a term used where we change the composition of a thin layer of metal on the outside of an item, like this shaft, by adding carbon to it in one of several different ways. It is then heated to a suitable temperature. We then quench it by immediately plunging it into water, oil, or a salt brine solution. Since only the outside, or as it is called, the outer case, receives additional carbon, it is the only part that gets hard. Through hardened is the term used when a material is essentially the same hardness all the way through. Centrifugal force is the force which makes an object tend to sling outward from a body which is rotating. It is centrifugal force which is trying to pull the string out of your hand when you whirl a rock on the end of a string. It is also centrifugal force which holds water in a bucket when it's slung over and over. There's the water in the bucket. It's slung over and over, and the water stays in. It stays in because of centrifugal force, and use is made of this fact in the industrial centrifugal pump. Here we bring the fluid to be pumped into the center, sling it to the outside of the pump housing, which is called a scroll case. This slinging action can build up very high pressures. Coefficient of friction is a number which is assigned to indicate the relative ease with which one material will slide on another. For example, dry steel on cast iron at rest has a coefficient of friction of approximately 0.15. Leather on cast iron at rest has coefficient of friction of approximately 0.60. As you can see, steel slides on cast iron about 4 times as readily as leather will slip on cast iron. It should be noted here that the coefficient of friction for a body at rest is always more than one in motion, which is called sliding friction. That is to say, once something starts to slide, it takes less force to keep it sliding than it did to start it. O-rings are simply, as the name implies, rings of round material, usually rubber. They come in all sizes and are used as seals. Gaskets like this are also used as seals. They may be made of any of a number of materials. Pipe flanges. This is a pipe flange. They may screw onto a pipe or be welded. This one is a welded flange. This one is a screwed flange. They may be bolted together, or say to a valve, with a gasket in between. In this case, the pressure exerted on the gasket by the bolts completes the seal between the flanges. When O-rings are used, they are put in an enclosed groove, like the one on this 4-bolt hydraulic pipe flange. Then when the flange is bolted on, it comes down metal to metal. Remember the margarine? Okay, we're cutting a cross-section right through here. Like I said, it's bolted metal to metal right here, but this only slightly mashes the O-ring on top and bottom. Now, the pressure of the fluid in the pipe, when it's applied, forces the O-ring into this area, which makes a seal like this. Bimetallic is a term meaning two metals. Here, once again, use is made of the property of metal called thermal expansion. That is, heat it, and it expands. Since different metals expand at different rates, if we bond two different metals together and heat them, since one expands faster than the other, the strip will bend. Bimetallic elements are used in thermostats and heat-sensitive elements throughout industry. Radial load is load which is at right angles to the shaft. Axial load is loading along or parallel to the shaft. Axial load is also called thrust load. Pulley or sheave is a loose term which is used in several different applications. This is a pulley. This is a pulley. This is a pulley. This is a pulley. A pulley, then, is a wheel upon which a belt, rope, or chain of some type operates. Bearings are units which permit motion between two moving bodies without excessive wear. Sleeve bearings are bearings which wrap either partially or completely around a shaft. Normally, bearing surfaces are of a different material, either harder or softer than the shaft they operate with. For example, a steel shaft running in a brass or Babbitt bearing. Babbitt is a material widely used as a bearing material. There are a number of different alloys, most of which contain tin, lead, and antimony in varying proportions. Connecting rod bearings and main bearings in automobiles are of Babbitt. Roller and ball bearings use two races, one inner and one outer race. These are races which are of hardened steel. Grooves are machined into these races and then hardened. Steel balls or rollers are used to transmit the rotation. Most bearings require a lubricant of some sort, and oil or grease are the two most commonly used. Grease is a mixture of oil and a soap to make it stiff. The oil in the grease is what does the actual lubricating as it slowly bleeds out of the soap. In the case of the sleeve or journal bearing, the whole load is supported by the oil film, and in a properly designed bearing, the two parts never actually touch except when the unit is at rest. Well, now I hope you have a basic understanding of some basic terms. I'm Dave Brown for Teletrain.